so I have already shown the height and the width, or what the monomial and the binomial represent. So on the left-hand side, they have two negative y tiles, and then a negative y tile plus two constants 1. Sam is going to draw in the resulting area model, and then we're just going to ask her a couple questions about what she's done.
Okay, so this y and that y makes negative or positive x or y squared.
Good, excellent.
And the same thing happens down there.
Good. So make sure, just like Sam has done, if you take a negative y tile and you multiply by a negative y tile, you're going to get a positive y squared tile. So height of y, base of y, the negative times the negative gives you the positive.
Okay, and then this y, negative y, and the 2, or the 1, would represent a positive y. Negative.
Why a negative, Sam? Negative times a positive is? Good. So if one's colored in, one's not colored in, negative times a positive, you make sure that you color it in, because negative times a positive is negative.
And then the same way down here.
Good. So now that Sam has drawn the area model representation, what is the polynomial that's represented, or the resulting polynomial? Who can tell Sam, what is the resulting polynomial that she's drawn? Tori?
2x squared minus 4x.
Good.
Or 4y, sorry.
Okay. So the only thing is, I guess if we put y and then Tori corrected it afterwards, I'm just going to go back and put this and make it a y. So perfect. Thanks, guys. Okay, so I want you guys to take note of something. We started, and this is how it's been for this unit. We start with the modeling, and then we move away from the modeling and try and do this symbolically. Okay, symbolically meaning show me what the terms are. Try not to use the pictorial representation. So I have wrote on the far side the same 3 examples. Obviously, if they're the same 3 examples, we need to get the same answer. So how can we go straight from this 2d multiplied by 3d right to 6d squared? How do I get that solution? Blake.
2 times 3, and then 6, and then just add on the d.
Okay, so Blake says 2 times 3, which is 6, and then you add on the d. So we'll look at what you mean by adding on the d. Question for you, is there a difference between me saying 2 times 3 or 3 times 2? No, there's not. You're still going to get the same product, right? The result's the same. So when I write something like this, I can rewrite it as 2 times 3 times d times d, because they're all being multiplied together. Remember that? If I draw a little dot, it means multiplication. Okay? The reason why I'm doing the dot is because if I put an x, you might think it's a variable x. So now that I have this, 2 times 3, we all know that it is 6. But what do you get, or how do you simplify something when I say d times d? Think back to chapter 2, d times d, or a variable times itself. How do you simplify that and express that?
D squared.
Yeah, d squared. Okay. So you get 6d squared. So if I take a look at the second example, yesterday what we said, if it was just a constant and we multiply it by that polynomial that we had, it made a certain amount of groups of that. So it applied to each term. So same thing here, 3x, you have to multiply it by each term. You multiply it by the 2x, and you multiply it by negative 2. So I can rewrite this as 3x multiplied by 2x plus 3x multiplied by negative 2. Well, same thing that we did up above, this is the same as 3 times 2 times x plus 3 times negative 2 times x. So when I simplify this, 3 times 2 is 6, x times x is, yeah, x squared, plus 3 times negative 2, which is negative 6, and then the x. Try the next one on your own. How are you going to show me the work that you've done?